We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Since the very first successful landing of a wheeled rover in 1997, NASA and Jet Propulsion Laboratory engineers have managed to design, build, and launch 5 rovers to the Red Planet in search of extraterrestrial life. JPL has made it a priority that each iteration of wheeled rover is to be improved upon from its predecessors, therefore each rover differs in significant ways. The first 2 wheeled probes to rove on Mars after NASA's Pathfinder mission in 1997 were Spirit and Opportunity. Both launched in 2003 and are almost identical to each other. Each rover was also supplied its power through solar panels. Not long after the solar panels proved to be a major liability for long-term service life, engineers decided to implement radioisotope thermoelectric generators, or RTGs, as a power source for their next-generation rovers, Curiosity and Perseverance. Through these subtle but impactful improvements in technology, NASA has been able to establish themselves as the leaders in Mars exploration. They have been responsible for 6 out of the 7 rovers that have landed successfully on the surface of Mars. Probes come in all shapes and configurations, and while some have increased in size or have improved methods to generate power, none have been quite as unique as Ingenuity. The Mars helicopter in and of itself is an engineering marvel. Although only standing at half a meter tall, Ingenuity is one of NASA and JPL's most ambitious and one-of-a-kind projects. Its mass comes in at 1.8 kilograms on Earth. However, on the Martian surface the helicopter will weigh just half of a kilogram. Ingenuity was specifically designed to fly in Mars' less dense atmosphere and will provide necessary telemetric data to engineers. The Martian helicopter is first and foremost a technology demonstrator, and it has recently become the first aircraft to make a powered and fully controlled atmospheric flight on another planetary body. Quite the accomplishment for such a small probe. NASA and JPL have since described the Ingenuity flight as the Wright brothers moment. Becoming the first probe to achieve powered aerodynamic flight on another planetary body is quite a hefty accomplishment. To commemorate this occasion, a small piece of fabric from the wing of the Wright Flyer was attached to a cable on the underside of Ingenuity's solar panel. This small detail helps to celebrate the immense progressions of humanity. Ingenuity and Perseverance were launched aboard an Atlas V rocket in July of 2020. The 2 probes coasted through the endless vacuum of space for 6 months until they were pulled into Mars' sphere of influence just before the landing procedure initiated. The landing procedure of Perseverance went as smooth as it could have, with vital systems functioning nominally. Soon after Perseverance's heroic landing on February 18, 2021, Ingenuity was detached from the rover on April 3. 5 days later, on April 8, Ingenuity spun up its blades for the very first time on the Martian surface, achieving a low-speed rotor spin of 50 revolutions per minute. NASA then determined that a software update was necessary for further testing. This delayed the first flight to a later date. On April 17, Ingenuity passed a full-speed spin test, achieving a 2,400 revolution per minute spin rate while still remaining on the surface. Finally, on April 19, Ingenuity became the first aircraft to achieve aerodynamic powered flight on another planet. It flew for a total of 39 seconds, rising 3 meters in the air, rotating 96 degrees in place, and landing. Ingenuity is specially designed and engineered to function in a complete Martian environment. Because the atmosphere of Mars is much less dense than that of Earth's atmosphere, it is much more difficult for an aircraft to generate lift on the Martian surface. To combat this issue, JPL engineers implemented contra-rotating coaxial rotors that are 1.4 meters in length. The increased length of the rotors allows more surface area and thus more atmosphere for them to grab onto. This, in combination with a rotor spin rate of 2,400 revolutions per minute, helped the small helicopter achieve the necessary lift required. All of this accomplished while being completely electric and rechargeable by a small solar panel. The idea of a Mars helicopter had been around since 2014. JPL published the conceptual design back in 2014 for a Scout helicopter to accompany a Martian rover. Funding of $15 million was requested through 2016 to keep the Scout helicopter design on track. By 2017, engineering models of the vehicle had been tested in a simulated Martian atmosphere. Extensive flight dynamics and communication testing was performed to ensure successful flight. Ingenuity was to be controlled telerobotically, meaning a delay would be present from controllers on Earth to the helicopter on Mars. After a successful test campaign, Ingenuity was finally mounted onto the underside of Perseverance in August of 2019. Overall, NASA had invested nearly $80 million to build Ingenuity and an additional $5 million to operate. So what exactly is the purpose for NASA building a helicopter for use on Mars? Could there be any benefits to taking on this challenge? And are there any advantages that could prove to be worthwhile? The answer to these questions is an overwhelming yes. Ingenuity's main purpose is to serve as a technology demonstrator for potential use of flying probes to explore terrain inaccessible to rovers. The helicopter is expected to fly up to 5 times during its 30-day test campaign. The flights will be estimated to be around 90 seconds long and perform a series of technological demonstrations that will look to be implemented into future rotorcraft designs. NASA's JPL will look to assess whether this technology can fly safely and provide better mapping and guidance parameters. I now want to discuss the various benefits of utilizing aerial vehicles for scientific and exploratory purposes. The use of unmanned helicopters on atmospheric planetary bodies will allow rovers on the ground to travel more distance over their lifetime. Ingenuity, for example, is designed to provide overhead images with 10 times the resolution of orbital images, and will provide images of features that may be occluded from the cameras on Perseverance. This kind of scouting may enable future rovers to safely drive up to 3 times as far per Martian sol. If you implement this design into other advanced helicopters, it would allow planning of driving routes to be more flexible due to having more visual reference. This concept can also be applied to when astronauts visit the Red Planet. The helicopters will be the eyes of the astronauts and Mars. Another potential use is for larger helicopters to carry science payloads and investigate multiple sites where rovers cannot reach, such as canyons or crater walls. These future rotorcrafts could very well be in the range between 5 and 15 kilograms with science payloads in the 0.5 and 1.5 kilograms range. Potential aircraft could also have direct communication with an orbiter and may or may not continue to work with a landed asset. These advanced concepts have the potential to explore unattainable sites where microbial life could survive. Many have also speculated about the idea of using Ingenuity's rotors to blow Martian dust off of solar panels. Most notably, the panels of Insight and Opportunity. While certainly an ingenious proposal, it is just not feasible. Ingenuity was designed for the sole purpose of demonstrating flight dynamics on another planet, not for blowing dust off of solar panels. Assuming that Ingenuity will be able to recharge efficiently for up to hundreds of trips across Mars to reach these probes, there is no guarantee that this will work. So, ultimately, it is just not worth it. Ultimately, the reason why all of this is important is because Ingenuity could form the foundation on which more capable aircraft could be developed for aerial exploration of Mars and other planets. The exploration of planetary bodies through aerial vehicles is something that is currently in major development, and depending on Ingenuity's tests, we could possibly see more in the very near future. The most notable mission that comes to mind of many is the Dragonfly mission and spacecraft. Dragonfly is a NASA-planned rotorcraft that will visit Saturn's moon Titan. Part of the New Frontiers program, Dragonfly will intend to make the first powered and fully controlled atmospheric flight on a planet's moon. This revolutionary mission concept includes the capability to explore diverse locations to characterize the habitability of Titan's environment, to investigate how far prebiotic chemistry has progressed, and even to search for chemical signatures that could indicate water-based and/or hydrocarbon-based life. all while using its vertical takeoff and landing capability to travel between exploration sites. Expected to launch in 2026, Dragonfly will serve a big role in our quest for the answers to Titan and the universe. It is a mission that I am personally very invested in. It is exciting to see the powered flight of rotorcrafts begin to take their form in preparation for future missions. Proving that we can control powered flight on a less dense atmosphere is an important first step in reaching the rest of humanity's goals. The flight data from Ingenuity is something that we will study for the next decade as more rotorcraft designs are being implemented into spacecraft. After several successful flights from Ingenuity on the Red Planet, JPL has collected flight data that can support future iterations of rotorcraft destined for other planetary bodies or moons. At the time that I have released this video, Ingenuity is still in operation and is participating in its testing campaign. Now that you are aware of why this little helicopter is so important, make sure that you stay up to date for any announcements and discoveries from the JPL Ingenuity team. I hope that you have enjoyed this video. Leave a comment if you have any questions, and most importantly, take care.